Hi, this is a math problem from Math 2-3. This is one of the homework problems from page 481, problem number 5. This problem is about a suspension bridge. Sorry, the picture's a little blurry. And it says, imagine you are in charge of constructing a 2-tower suspension bridge over the Potlatch River. You have planned the curve of the main suspension cables can be modeled by this function right here. And this is what our whole problem is going to be based on. Basically, I was reading through the problem and I came across a equation. I know that's what I'm going to have to use. And then it gives me some information. It says y represents the height of the cable above the bridge surface. So we know that we are trying to find the height of the cable above the bridge surface, given that x represents the distance along the bridge surface from one tower to the other tower. And of course they're measured in feet. So x tells us how far from the left-hand tower to the right-hand tower we've traveled, and the height of the bridge is given by this equation right here. Part A says, what is the approximate height from the bridge surface of each tower from which the cable is suspended? Basically, we've got a tower here. I think I want black ink. Basically, we've got a tower right here on the left and a tower right here on the right and a road going between them. And suspension bridges look something like this. We're trying to find how much is the height right here, where this cable connects here and where it connects here. Notice that they gave us an equation. It was 0.004 x squared minus x plus 80. And this is the height. Please also notice that right here, where the cable connects to the left-hand side of the bridge, the value of x is 0. So if we plug in 0 to this term, it just goes away, because 0 times anything is 0. And if we plug in 0 to this term, it just goes away, leaving us just 80. That's the y-intercept. And it happens right here. Since parabolas are symmetric, and of course suspension bridges have to be symmetric, we can tell that this is also 80. Looking at more graphically, here's a better graph produced by the TI Inspire calculator app. I've put in the equation right here, and you can see if this is 10 feet high and this is 100 feet high up here, this should be 10, 20, 30, 40, 50, 60, 70, 80. It connects right there at 80 feet. We can draw a line all the way across here, and we can see that that also looks like 80. Notice that when I come down here, this number is going to be important soon. I've got the same graph here in GraphCalc HD. You can see the same information over there. It connects over there at 80. When x equals 0, when the distance from the left-hand tower of the bridge is 0, the height of the cable is 80, and that's what Part A is trying to ask us. On to Part B. What's the shortest distance from the cable to the bridge surface, and where does it occur? I'm not going to care that that's red this time. Here's the towers of the bridge. Here's the suspension cable. This is the road. We should be able to see that halfway in between that tower and that tower is going to be the lowest point, and it's right about here. So if we look down here, we can see that the height of the cable is at its lowest point right here, and that happens halfway between the left-hand bridge and the right-hand bridge. We're not exactly sure what this distance is yet, though. I'm going to refer again to a calculator. This is the calculator the TI Nspire calculator app right here, and I've used it not only to graph the equation. Here's the equation, here's the graph of the parabola, but I've used the trace function to find the minimum point on it. This is a very powerful app that you should purchase so that you can use it. And this tells us that at 120 feet from the left-hand bridge, that's what the value of x is, the distance from the left-hand tower of the bridge, at 125 feet, the height of the cable is 17.5 feet. Looking at the same information on GraphCalc HD, I used up here the trace function. When you click on trace, it gives you some options, and one of them is snap to the minimum or maximum point. And when I put my finger anywhere near the minimum, it's snapped towards the minimum, tells me that the minimum is found, and that the x value is 125 feet, and that the y value, representing the height, is 17.5 feet. See? Same answer. Notice I didn't try to calculate that from the equation this time. We'll get to that soon. Part C. At which point is the suspension cable at least 50 feet? Alright, that's an important couple of words right there. That says, when is the cable at least 50 feet? At least means 50 feet or greater. So at least 50 feet means 50 feet or greater. We want to write an inequality that represents this question. Inequalities are the less than or greater than. And because it's at least, it means it could be 50 feet or it could be more than that. So we start out simply by writing our equation, 0.004 x squared minus x plus 80. And we want to solve this for where this is greater than or equal to. I've drawn that a little bit big so you can see which one it is. 50 feet. So what we're looking at here is the equation, which is the height of the suspension bridge. Where is that greater than or equal to 50? Well, let's, again, use an app on the iPad and see. Over here, I've used the iPad app for the TI Nspire graphing calculator again. It still shows the minimum, and it still shows the equation, but I've also put in another equation, just where f of x equals 50, or in other words, where y equals 50. So that's this line right here that passes through over here, the point where y equals 50, the height is 50, and we can see that there's between 0 feet, between x equals 0 and x equals 34.9. I'm going to round that off to 35 feet, by the way. And over here, similarly, at 215 feet from the left up to the right-hand bar, the right-hand tower rather, which is 250 feet. Looking at that on the GraphCalc HD app, what I've got here is I've put in the equation, and you can see the graph of it in the background there is red. We'll see it better in a second. And I've also put in the equation y2 equals 50. That's going to give me a straight line from left to right at 50 feet. So when I press save on that, again, I'm using the trace function that's up here. Right now it says pan zoom. That means switch back to the pan zoom screen. This is what it looks like after I've pressed trace. I can trace and say snap to the intersections. So I looked for the intersection of the green line, which is 50 feet, and the red curve, which is the height of the suspension bridge. And I found one of the intersections, and that happens at about 35 feet from the left-hand tower, about 35 feet from the left-hand tower. And notice that the height for both the red equation, which is our suspension bridge, and the green equation, which is just the straight line at y equals 50, they match. So it's the intersection. Similarly over here for the other intersection point. Again, where is it 50? And that's at when the distance from the left-hand tower is about 215 feet. Now this is important. We're looking for this part of the graph over here where the height of the bridge is greater than or equal to 50, and this part of the graph over here where it's greater than or equal to 50 feet. we are not looking for this part. All of this part down here is where it's less than 50 feet, and that's not what we're looking for. So here's our inequality again. I say inequality, not equation, because we've got an inequality symbol here, greater than or equal to 50 feet. So the answer that we came up with was, we want to know x is between 0, there's x, the distance. When x is greater than or equal to 0, and when x is less than or equal to 35 feet. That's one of the two places where this inequality was true. And when x is greater than or equal to 215 feet and less than or equal to 250 feet. Remember that the middle point was 125, so the right-hand tower must be 250. And this is the answer to part C. This whole big thing right here. If you're having trouble with this notation, we should talk about it. It'll be mentioned in class a couple more times. Thank you. That's all of it.